So welcome to my talk on Back to the Future, Swift 6 edition. Couple of disclaimers before I start. It's not Back to the Future themed. Actually, I wish it was, but I didn't really have the time to do it. And yeah, another thing, I didn't realize this was a 90-minute workshop slot. So I prepared my talk for a 60-minute slot. So we might be a bit shorter, maybe longer break. It's nice if you've got loads of questions. This is your chance to ask them as well. You've got 30 minutes to ask them, even longer maybe. So before we kick off, I'm going to quickly introduce myself. My name is Pol. I'm an app maker and content creator based in Barcelona, in Spain. If you notice something weird about my accent, I lived here for about 10 years. My girlfriend is Scottish, she's from Glasgow. So if I start saying weird words, like my accent sounds from all over the place, that's the reason why. Yeah, I spend most of my time working on the customer iOS app at Glovo, which is a food delivery company based in Barcelona. They're originally from there, but they operate all over Europe. They operate in Africa and Asia as well. I also have 3 indie projects that I currently ship and build. One of them I ship and build on my own called QReate, which is a QR code generator and editor for macOS. And the other 2, I work with my good friend Hide here. One of them is NowPlaying, which gives you facts and trivia about your favorite music, artists, and albums. And the other one is Helm. We've been working on it very hard recently. And basically, it's a native macOS client for App Store Connect. We're trying to put a lot of our frustrations and trying to fix a lot of the frustrations we have when shipping in App Store Connect into a macOS app that does a lot of the heavy lifting for you. And talking about Helm, this was meant to be an exciting announcement that we were shipping the app today, but I had to edit the slide last night. So we're shipping it when Apple actually approved it. So yeah, basically it's stuck on in review. It was stuck on in review, then we tried to reject it, and then it got stuck in canceling mode, basically. So yeah, whenever they approve it, we're gonna ship it and we're gonna release it to you all. If you wanna check it out, that will link you to the website so you can basically stay updated. We've got a Twitter account and you can follow us both on Twitter as well to get updates and hear when we actually ship it. On top of the app making and iOS development, I also create a bunch of content. So I write weekly articles on my blog, which is polpiella.dev. And I also run a newsletter about iOS CI/CD that I post every couple of weeks called the iOS CI newsletter. I made this little logo into stickers as well that I brought with me. So if you want any stickers, just come up to me and I can hand out some. I recently also started working with Runway, who also happened to be sponsoring the conference. And yeah, they basically focus on release management and mobile DevOps, essentially. They're also running, as you heard earlier, they were running a cool giveaway of the Space Shuttle discovery as well, a Lego piece. So if you want to participate, just make sure you go and chat to them. Cool. I also like to end my intros with some personal facts about myself, so you get to know me a bit better, like as a person. One fact that I usually share is that I collect football shirts. I've got over 150 football shirts from teams from all over the world. And it's a tradition that I actually started when I was a kid. So my parents used to travel a lot for work. And every time they would travel, they would bring me back a football shirt. And as an adult, I actually kept this tradition going. And I've got like teams from all over the place. I don't particularly know which team to get here in Folkestone. I don't know if there is a football team I can get a t-shirt from. But yeah, if you do know, do let me know and I'll get the t-shirt. Basically, I try to get one every time I visit somewhere. Awesome. So now that the introductions are out of the way, this is what I'm going to talk to you about today. So I'm going to talk to you about how to get ready for Swift 6. So before we actually go into what's changing in Swift 6, we need to understand that Swift 6 is the first major version of Swift since 2019. So it's been over 5 years now since the last major release of Swift. And it's kind of causing like a lot of confusion. It's kind of causing a lot of like drama in the community because there's a lot of like data race check-in and a lot of structured concurrency check-in, and people think that their apps are going to break, like in Swift 6. And it's kind of understandable that you're quite scared of adopting a new version of a library. You tend to be scared when you adopt a major version of a library from a third-party dependency. And more if it's like your programming language, you probably, you're right to kind of like feel, a bit wary of adopting the library and what's going to actually break. If you're familiar with semantic versioning, whenever you define a new version in Semver, it has three main components, basically. So you've got the patch version. So whenever you adopt a new library, a new version that's a patch version, you probably have nothing to worry about. It's got no source breaking changes, and it's usually around like bug fixes and small updates that you need to bring into your library. Minor version is basically also non-breaking, so it has source compatibility with your previous version that you already had adopted, but it has some more considerable changes. So it probably has like a bigger, update of the library, maybe some architecture changes, but it shouldn't break source compatibility. And the major version, which is Swift 6, basically, it's what we're gonna get, actually is meant to have or could have breaking changes. You usually bump a major version whenever you've got breaking changes and you've got like some form of source incompatibility with prior versions, and you denote that by bumping the major version of your semantic versioning in the library. And if you pair this fear that it could introduce breaking changes with all the amount of work that Apple have been putting behind the scenes in Swift Evolution, all of these Swift Evolution proposals are the ones that are actually implemented in Swift 6. Out of these evolution proposals, there are 12 that actually introduce breaking changes. So all of the ones that I marked in red are the ones that introduce breaking changes and are going to have potential for breaking your application in the future. There's a bunch of stuff that changes in these 12 proposals, and most of it is around strict concurrency checking and data race safety, basically. But yeah, just so you know, there are 12 proposals that have been implemented already, and there's probably more that are being accepted and reviewed at the moment that introduce breaking changes that have potential for breaking your application. So at this point, before I go into that, this is when I try to enable strict concurrency checking in an app that we've recently started working on with a fairly small code base. I got 452 warnings, basically. So these 452 warnings, there's probably 10 that aren't going to break, that we've put there to kind of have to do some stuff. But out of those 450, probably 400 of them are going to be errors in Swift 6. So it's quite worrying, and you're probably feeling a bit like this. Sitting there, you're probably thinking, no, I've got, if this is a small code base, imagine if you've got like a major code base with loads of Objective-C. Imagine you've got like a lot of legacy code and code that no one like dares to touch with like some complex business logic. What's actually going to happen in Swift 6? Well, what are we going to do? You might actually consider career changes and alternatives. So this is a meme that actually went around and it became very viral. Someone who worked at Microsoft for 22 years and then became a goose farmer. Turns out, I looked into the story a bit. They were already interested in goose farming and they already had a farm and everything. And then they left Microsoft and did that full time. So yeah, Swift 6 might be the time to explore new career paths. But the goal of this talk is basically to tell you that you've got absolutely nothing to worry about. There's no time pressure on adopting Swift 6. And this is because we need to really differentiate between the Swift 6 compiler and what's going to come out in the beta and the Swift 6 language mode, right? So all of these breaking changes are actually going to come in the Swift 6 language mode and not in the Swift 6 compiler. And by default, whenever you migrate a project from Swift 5, from your compiler in, say, a beta version or in a Swift toolchain over to Swift 6, it's still going to build with the old language mode. So technically, even if you bump to a new major version of Swift, you're not going to have any breaking changes. And if you don't believe it from me, which you're entitled to, who's this person talking to me about Swift 6, believe it from the engineering manager at the Swift language team, who's been very vocal about this and has really helped and like bridged this gap and these like holes in knowledge that I certainly had. I personally thought that whenever you move to the Swift 6 compiler, your app was absolutely going to break and you really had to prepare for it. But she basically explained that the Swift 6 language mode is going to be an opt-in feature that you can adopt at any time. There's no reason to kind of like be scared and rush because there's no time pressure. You can adopt it anyway. You can also adopt it a feature at a time. So you can adopt a module at a time. You can migrate certain features, choose to adopt some strict concurrency checking, choose not to adopt some other, choose to adopt certain Swift 6 language mode features, but no other ones. And also something very interesting that you can see in one of the replies is that Swift 6 code can actually, Swift 6 language mode code, can actually depend on libraries that use Swift 5 language mode. So if you're a library maintainer and you actually enable Swift 6 language mode in your library, projects that use the Swift 5 language mode can depend on your library with no problem, and vice versa as well. So it's very, very like source compatible. It works in a very nice way. I'm sure we're gonna find like some issues at some point and some edge cases that like the Swift team will actually have to go and fix. But so far, it's a major version, but it's adopted in a very nice way, in a very developer-friendly way, so that you can basically manage your priorities and adopt it at any time. So yeah, see, no point like worrying about it. It's absolutely fine. You can adopt it at any point. If you want to get more information, there's an absolutely amazing episode of the Swift Package Indexing podcast with Holly Borla, with the engineering manager of the Swift language team. I honestly can't recommend this podcast enough. I had a ton of questions about the Swift 6 compiler and Swift 6 language mode. This podcast answered every single one of them. It's amazing. It's super like engaging and entertaining. So yeah, make sure you check it out if you're interested in the topic and you want to make informed decisions about how to migrate to Swift 6 and the language mode. So having said this, we reach a point in the talk where we could do this. Sorry, not yet. So. Yeah, out of all these features, I'm going to show you that the ones that are red, as I said before, are the breaking changes. But whenever you enable, so if you migrate to Swift 6 without the Swift 6 language mode enabled, all of those breaking changes disappear. So you've got nothing to worry about. And you can migrate to Swift 6 with no problem. And you can get the Xcode betas that actually use the Swift 6 compiler without the Swift 6 language mode. So you can basically adopt it at no cost. And we reach a point in the talk where I've just said, how to get ready for Swift 6. Well, you don't really need to get ready for much. So we could just like enjoy the sun outside. We could go for some pints, have a longer break and everything. But instead, I'm going to choose to be a bit boring, and I'm actually going to show you how to get ready for the Swift 6 language mode, right? So for the rest of the talk, I'm going to go through every single breaking change that they've introduced. Except for one, and you'll see which one I chose to ignore at the end. Yeah, and I'm going to show you what you need to do to enable those now and to start getting ready for Swift 6 in your application. So the first thing that you need to know is how do you actually download Swift 6, and how do you start adopting these changes, and how do you start preparing for them? You've got two ways. The first one is downloading a Swift 6 toolchain. A while ago, they announced in the Swift.org forums that the Swift 6 release process. So on the 15th of March of this year, they created a release branch, and regularly they basically update the snapshots, and they upload snapshots to the Swift.org website, so you can basically go and download them. So this is what the website looks like. You've got a ton of different platforms. So if you're doing stuff with Swift on the server, you've got Amazon Linux too, you've got Ubuntu snapshots as well. For mainly what we'll be interested in, if you're doing an iOS or macOS target application target, you will usually download the Xcode toolchain, basically. You can do this manually, and you can manage your toolchains manually, but I would encourage you to use a tool for your command line that actually does this. You can use SwiftTemp, for example, for macOS. So you install it with a brew command, you add something to your shell configuration file, and it's all set up for you. And at this point, you can basically install a snapshot, just like this. Very, very simple. You can install the Swift 6 development snapshot. You can use it in your Swift package, for example. You can see the Intuit, and then use it as a local toolchain. So this will create a Swift version file in your directory. I would thoroughly recommend to use the local one. Do not set your global Swift toolchain to a development snapshot, because you'll run into a ton of issues. You'll forget you have it set as a global snapshot, and then you'll run into a bunch of issues that and you won't know why, and you'll have to figure out why. Awesome. So you can do this. And in Linux, I would recommend checking out a tool that the Swift server workgroup have actually made called Swiftly. It's only available for Linux at the moment, but you can do a very, very similar thing. Instead of brew, you do a curl command and you can install it. And then you just do very, very similar. You install the development and then you use it like that. So if you're doing any Swift on the server, this is the code to go to if you want to build your package for Swift 6 using a Swift 6 toolchain. So we're going to see some code now. This code actually introduces an error in Swift 6 in the language mode. If you've got strict concurrency checking enabled, which I would recommend that you do this now, it will give you a bunch of warnings, and this code will result in a warning. The reason why is that we've got an actor class, so it's isolated to a specific context. So your class is basically thread safe by making it an actor. And then you're basically calling a method from an isolated class inside that actor. So you're essentially transferring, and this is what the warning will tell you, you're transferring this isolated actor into a non-isolated context. In Swift 6 language mode, this will result in an error, basically. In Swift 5 language mode, with strict concurrency checking enabled, this will result in a warning. So what happens if we grab the Swift 6 toolchain that we've installed and used, and we build this code with it? So we can go into the terminal, we can do Swift build on a Swift package, and you will see that we've got a warning, right? This is using a Swift 6 toolchain, so this proves the point that we're building with the Swift 5 language mode. So how do you actually go and enable the Swift 6 language mode to make this into an error? Well, you've got two ways. The first one is in your package.swift. You can basically change the Swift tools version to 6.0. And then there's a nice Swift language versions parameter that you can pass, and you can choose the version to 6. You don't get the benefit of an enum. I think you get it if you change it to Swift 6.0, but if your Xcode has an older version of the Swift tools, you need to write it like this, basically. You need to pass a custom version like this. There's another way. If you don't want to modify your package.swift, you can basically pass this parameter directly from the terminal. So you can pass some compiler flags to the Swift compiler. You can do -swift-version and specify number 6, basically, to build with Swift 6 language mode enabled. Awesome. So if we go back to the terminal, you will basically see that whenever I run Swift build, I now get an error. So this is exactly how you enable the Swift 6 language mode for Swift packages. Now, you will have realized that I'm talking a lot about Swift packages, and I've not talked about Xcode projects and app targets. And the reason why I haven't is because I did a lot of research to trying to enable the Swift 6 language mode on this. And the TLDR for this part of the talk is that I basically have no idea how you enable the Swift 6 language mode in Xcode for an app target, which for me was the most useful case that I wanted to test for my apps. I actually don't think you can, and I'm going to run you through what I tried. And this is more of an open question to anyone. If you know how to do this, please do let me know, because I'm really interested, but I haven't found a way to do it. So what you can do in Xcode is you can basically select a toolchain, right? So you can go on Xcode toolchains and you can select from the list of the ones that you've got installed. So this is a dynamic list, right? So what this means is that whenever you install a toolchain in your system, Xcode will look for them and it will show them on the list there. Now, the problem is that if you build, as I said before, the Swift version or the Swift language mode will still be 5, right? How do you change the Swift version? So you basically change it on a target build settings, and you can change it. There's a parameter. I don't know if you can see very well. It's very small. But there's a parameter. There's a settings called Swift language version. And you've got a list there that you can select from. As you can see, I'm using the Swift 6 toolchain, but I don't have Swift 6 available as a Swift language version. The reason for this is very annoying, but this list is actually hard-coded and it ships with Xcode, so it doesn't really check what toolchains you've got installed, what versions you've got available, so you've got no way of actually selecting Swift 6 with the toolchain. You could set it as unspecified, but that will basically give you an error saying that the Swift version can't actually be unspecified. So I started Googling. I went down a massive rabbit hole to try to figure out how this works and try to test my apps with the language mode enabled. And I found this thread on the Apple forums from an Apple engineer. And this comment basically says that you used to be able to do it one of two ways. So the first one was by using the legacy build system in Xcode, which basically ignored the Swift version altogether. So you could just build with whatever the toolchain wanted. And the second one, you could basically go into the Xcode package contents, go into one of the plugins, and edit the list of Swift versions manually, and add Swift 6 into it, and then it would show up in Xcode. So you would have to do a bit of hacking to actually find this out. It turns out when I tried this plugin file does not exist. This is from 2018, so no wonder it doesn't exist. It's been like 6 years now. So yeah, that's not possible either. So I actually didn't really find a way of editing this list. Another thing that I tried was using xconfig files. So xconfig files allow you to define build settings for specific schemes. So you can basically load them into your configuration for your project. So I tried using the Swift version, right, and set it to Swift 6.0. This gave me very false, like high hopes. It made me very happy very briefly, because when I went onto the project, I could see that my Swift version for debug, where I had the configuration set, was 6.0. So I was like, okay, I'm onto something here. But if you look at the target, it says it's Swift 5. So it kind of like falls back. If it can't find it, it goes back to Swift 5. And yeah, as far as I know, there's nothing you can do about it. If you do know otherwise, please do let me know, because I'm really, really interested in trying this and finding a solution for this. So how do you actually test these features in Xcode? And how do you actually test them for app targets? Because if you can't enable the Swift 6 language mode, how do you actually enable these features and get your app ready for the Swift 6 language mode? Well, you test them through upcoming features. So upcoming features was a feature that was actually implemented in Swift 5.8 as part of this Swift evolution proposal by Doug Greger. And it's built specifically for the Swift, for enable small features that are going to be breaking changes in the Swift 6 language mode, so that people could actually adopt them in Swift 5, in Swift 5.8, 5.9. They could actually enable certain features that are coming in Swift 6 language mode without actually needing the Swift 6 language mode. You can imagine how much is changing in Swift 6 that we need a whole like feature and an evolution proposal just to enable those breaking changes. But this is absolutely great. Like this is amazing. But how do you actually find these upcoming feature flags? Well, you can go to the Swift Evolution website, and for every feature that has an upcoming flag, you can check when it was implemented. So when the feature was implemented, in this case, access level modifiers on import declaration was implemented in 6.0, and it's got an upcoming feature flag, which is internal imports by default. Then you can basically go to your Swift package, and in Swift settings, you can enable an upcoming flag like this. So this is the best way to test Swift 6 language mode features that are going to be breaking changes in your app without actually enabling the Swift 6 language mode. And this kind of shows that you can adopt just what you need or just what you want for the feature, and you don't have to adopt the whole Swift 6 language mode. You can only you can adopt like a piece at a time to not make that many breaking changes. Again, in Xcode for targets, there is a Swift flag that you can pass. So for your scheme, you could enable, for example, only on debug. You can enable an upcoming feature. It's a bit more cumbersome and weird to do it like this than in the package.swift file. But yeah, one thing you need to know is that you need to enable it for every single framework and every single Xcode project that you have. So if you have an app that's modular and you've got like a ton of frameworks, you need to enable it for every single one. So enable it in your app target will only affect the code in your app target. So yeah, it's on a per framework basis that you need to adopt and implement. There is a nice little conditional statement that you can actually use that will make the compiler check if you have a feature. So this is the same as doing if OS macOS or if OS iOS. You can check if you've got an upcoming feature enabled. It works in a similar way. As soon as you enable the feature for that scheme, it will highlight the code and it will hide the code that's not going to execute as part of this. This is pretty handy if you want to start adopting these features in production code, and you want to make sure different schemes can have like different settings, so debug or release, and you want to enable those features only for specific schemes. Awesome. Another thing you need to be aware of, and that has caused me a lot of confusion in the past, and specifically trying things out for this talk, is that a feature can actually be implemented in a Swift version. And this is very, very strange. So this specific feature was implemented in Swift 5.7, but the upcoming feature flag was only implemented in Swift 6.0. So if you're trying to adopt this upcoming feature flag in 5.7, it won't work. Basically, you need to go on the Swift 6 toolchain when the feature flag was implemented and then try it there. Awesome. So now that we know how to enable these features, I'm going to show you a very, it was going to be a very quick tour. I'm going to stop a bit more because I have the time to do it. So it's going to be a not so quick tour of the Swift 6 breaking changes. And I want to keep reiterating that this is the language mode, okay? So not the Swift 6 toolchain, but the actual language mode, the Swift version 6, that is opt-in from Swift 6. First one, and probably the biggest one, you can see a whole list of the Swift 6 migration process. And this is, again, from Holly Borla in the Swift.org thread site. You can see there is a list of proposals that are going to cause breaking changes. I'm going to go through all of them, and I think a couple more as well that are not listed there. But the biggest one that you probably should be worried about, and you should be, starting to adopt now, getting ready for Swift 6 language mode, is strict concurrency checking. When you enable this, this is very, very daunting, and it can cause you a lot of headaches, basically. The way you enable this is in a Swift package. This is not an upcoming feature, it's an experimental feature that comes with a ton of other upcoming features. You just enable this by saying enable experimental feature strict concurrency. If you've got a massive project and you don't want to, or a massive Swift package and you don't want to do this, I would recommend that whenever you start a new Swift package, you have this enabled already. I believe Massicode has a pretty cool Swift package template that already comes with this enabled. So I would thoroughly recommend using that whenever you start a new Swift package project. So in Xcode, you don't need to pass it to the other Swift flags, but they've made an actual menu where you can change the setting of strict concurrency. I would recommend you set it to complete. These are in errors, basically. It will give you warnings. So if you're happy to have a ton of warnings that you can fix every so often and you can keep fixing over time, I would recommend you just enable it now. The reason why you would enable it is that you actually learn a ton about strict concurrency. And over the past 3-4 weeks where I've been doing a lot of work with this, you actually learn a ton of things. One of the things that I learned, and it kind of blew my mind a bit, people might know about it, but I had no idea, is that an actual view, a Swift UI view, the type itself is not main actor isolated. Okay, so the view itself is not main actor isolated. That means that any methods you define in it are not main actor isolated. This kind of blew my mind because I was like, okay, it's a view, right? It should be bound to the main thread, to the main actor. It's not. The body of the view is actually main actor isolated, so you're safe to doing that. Something that I didn't know either is that the task modifier is also main actor isolated. So that's the context that you're going to get in there. So if you enable it and you're doing some code like this is some code that we've got to open a panel in Swift UI. We're using some AppKit. And the AppKit classes and the initializers are actually bound to the main actor. So you're going to get a ton of warnings that will become Swift 6 errors. The reason for this is that you're trying to call a method that's isolated to the main actor, not from the main actor. So this is the equivalent of trying to make published updates from a background thread. You would get a warning, basically. You shouldn't do that. But the compiler is actually checking this for you, not at runtime, but at compile time, which is pretty useful. The way you fix this one, for example, this is super, super easy. Probably most of the examples that you come across are not going to be that easy. But you decorate this with a main actor annotation at the top of the select file. And because we're using this only from the body, which remember is main actor isolated, it will just work basically out of the box. Another thing that you will probably find is that a lot of libraries and a lot of SDKs don't actually, they have sendable warnings, sendable related warnings, and concurrency and data safety related warnings. And you can basically suppress all of them. If you're not in charge of that code, then maybe you shouldn't really get the warnings about that code. You can suppress them by adding a small pre-concurrency tag before the import statement, and that will get rid of them. I would recommend filing some feedback. This is probably shooting myself in the foot because I now maintain that SDK as well. So if you want to file a feedback. I'm planning on looking into it at some point as well. But yeah, file some issue or something on their GitHub. Make sure that they're aware that they've got like some sendable related warnings and fix them in due time. But it's not like a dependency for you or a blocking issue for you. You can suppress those warnings by adding pre-concurrency. And something that really resonated with me and why I started to looking into this, because my point of view always with Swift 6 and with strict concurrency was like, oh, I really need to learn about this because it's going to become, a blocker in Swift 6. This should not be the mentality in my point of view. And in one of the articles that I was reading from Matt Massicott, who absolutely makes an amazing job of writing like the proposals and evolution proposals and talking about Swift concurrency in like very simple terms so that like I, for example, can understand it. And I've learned a lot from Matt as well. And one of the things he says is basically you turn on complete check-in to learn how Swift concurrency actually works. And this is super, super important. I learned so much by just turning that on that, it's super important to understand what you can and what you can't do. What's safe to actually do and what's not safe to actually do from a data perspective. Awesome. So as I said before, the strict concurrency check-in comes with an experimental feature that you turn on or an Xcode setting. And as you can imagine, with so many warnings and so many errors and so much like compiler analysis, people started realizing, and the Swift team shipped it, and it wasn't perfect, right? It was a work in progress, and they had to build more stuff on top of it. And people started realizing that it was flagging some false positives, and there were some funny like edge cases that were happening when you enabled strict concurrency. And they weren't clear, and people weren't really understanding why they were happening. So they started filing issues, feedback to the Swift team, and the Swift team has been like it's been like such a big priority for them to enable like full data safety and concurrent like access to data to be safe and to have the compiler check that for you, that they've built a ton of proposals and upcoming feature flags that now are breaking changes on top of the strict concurrency checking. So this is one that I particularly like, which is actor isolation property wrappers. This makes some Swift UI code work out of magic when it should really break. And this is why it's behind an upcoming feature flag, because when you enable strict concurrency checking, if they change this would break a ton of code. I'm going to explain how it works. I'm going to try and do my best to explain it. So, as I said before, a Swift UI view is non-isolated. Okay, so it's not bound to the main actor. So you can see at the bottom there, I've got a main actor isolated update UI. This, we saw earlier that there were some warnings to some UI kit code that was actor isolated, and we were getting some warnings, we were getting an error. So this is very, very similar code, right? So on view appeared, we're making a call to a method that's isolated to the global main actor. But technically, this shouldn't be allowed because our view appeared is not really main actor isolated. So we're making a call to something that should only run on the main actor from a context that's non-isolated. But to my surprise, this actually works fine. So there's no error in Swift 6 language mode. There's no error with strict concurrency checking. The reason why, it's pretty funny. It's this model thing. So model is isolated to the main actor. And you might be wondering, what does model have to do with anything? It's not even used in the view appeared. The update UI is not even part of the model. So state object, basically its wrap value, which is of type model, is isolated to the main actor, right? So that's something that the Swift team specified. What's funny about this is that if you've got a property wrapper that isolates some code to an actor, then its wrapper type becomes isolated to the main actor. So that means this whole view becomes isolated to the main actor. This is extremely weird, and people are seeing this, it works out of magic, right? Like, so this state object property wrapper makes the whole view work just out of magic. In fact, if you migrate over to the new macros, to the add observable macros, this code will give an error, basically. So you will basically face that condition. Now, they realized this was an issue that they had to fix, and this was something that wasn't quite clear. So they fixed this with an upcoming feature, so you can enable it as part, alongside the experimental feature. So if you enable this disable outward actor inference, you will basically see the normal behavior, which is that you will get a Swift 6 error. And here's a screenshot with the exact same code, but with the feature flag enabled. You will get the normal behavior. same one you would get if you had an @state macro, basically with the new stuff that they released in iOS 17. So I found that this particularly interesting. And again, I wouldn't have found this out if I hadn't turned on the flags and everything. So getting ready for the data race safety is not as easy as just enabling the experimental feature, but there is a ton of other stuff that they fixed along the way. I compiled it all together. If you wanna properly support strict concurrency and see what's gonna happen in Swift 6 when you enable the Swift 6 language mode, I would recommend take a photo of this and just enable all of these features, and you will see the proper data race safety. I'm gonna pause for the photos. I'm not trying to win time and stuff. Awesome. Cool. So I'm going to move away from strict concurrency check-in and sendable and all that stuff. Tim is going to do an amazing talk that I've seen before, and it's really worth checking out because he knows a lot more about sendable and all this stuff than I do. So yeah, make sure you go to his talk. Cool. Next one that I'm going to talk about is concise magic file. So this is a change that's probably not going to have a lot of impact, but if you've written any test code or any extensions that look a bit like this, you will probably have used this hash file property. Basically, you will have passed it as a default parameter so that people don't actually have to pass it. And then you will have used this file parameter in your asserts. What this does basically is that if you've got this code and these asserts in a method, it will actually get the file and the line where the method was called, and it will just talk to the Xcode diagnostics, and it will report the error in the right place. You can see here, I'm just using these assert instances are deallocated, instances are not deallocated, so I get a failure, and it's printing them and showing it in the actual place where the test is. This is particularly useful if you've got a modular code base and your extensions live in another module, your test extensions, because otherwise you would need to basically dig through a ton of code to actually find where the error happened. And it's not clear if you run a ton of codes in parallel, you want to know exactly which and where the tests actually run. That is, if you have tests in the first place. That's one thing you need to have to be able to have this. Cool. So this is actually changing. So if we enable this concise magic file, this file property, the value that it holds, is actually changing. So I've written a small test with that if hash feature that I talked about earlier. So in Swift 5, it prints the whole path. So the value of that hash file is the whole path to the file in the directory. In Swift 6 language mode, it's only the module and the file name. So it's no longer the full file path. And you might be wondering now, what impact does it actually have for me? What does it even matter? Well, actually, when I enabled this feature, I was getting a ton of warnings on my asserts. So yeah, you might want to actually check this. I thought initially that this wasn't going to be an issue. Maybe it's a warning that, because the assert, the exit test framework hasn't really changed at this point. I'm getting a warning that doesn't really matter. But when I run the tests, I wasn't actually getting any reports in the right places. So what I had to do is change hash file to hash file path, basically, which is the default parameter for the exit assert methods. I had to do this all over the place to get the reporting back in place. So this is something that you probably want to write like a script or something that does this for you. So it's something to be aware in Swift 6 language mode. This is actually going to change. So you might have some bits that you need to change, and you might have some issues with your test reporting. Another one is Regliterals. So this is something that has also been introduced and is going to be introduced in Swift 6 language mode. And this is something that's probably not going to break anything, but you might have seen some code online or some of the WWDC videos that introduce the reg exchanges, and you might be wondering why you can't actually use it. The reason why you can't use it is because it's behind an upcoming feature flag that you need to enable. The reason for this, to me, it's still a bit unclear where it can actually break things, but there's a bunch of stuff in the Swift Evolution proposal that says that if you've got some edge cases with some actual characters, then you will get some breaking changes and compiler errors. So it doesn't quite keep source compatibility. That's why they needed to enable this. So up until this proposal, this is how we wrote our awesome regular expressions that we all love and care about so much. So you basically wrote a string the string had no compiler safety. Basically, you would pass it onto an NS regular expression with your pattern, and then at runtime, it would basically check if the regular expression was actually good or not. People are against these force unwraps and force tries and everything. I'm absolutely fine with this because the first time you run it, you will actually see if it crashes or not while you're developing. Then if your pattern is basically a hard-coded string, then it's always going to succeed, right? So yeah, you shouldn't really worry too much about it. Now, this has actually changed. So when you enable the upcoming feature, which is /regex literals, you can basically write your regex expressions between 2 forward slashes. And as you can see, we're getting some syntax highlighting. We're getting compiler support as well. So if it's invalid, it will actually tell you it is. And when you actually find the matches and everything, if you've got any capture groups and named capture groups, you can actually access them directly through the output. It's extremely handy. Nothing, I think this was implemented in Swift 5.8 or 5.9. Nothing's actually stopping you from using this. Just enable the upcoming feature flag. Don't need to wait until Swift 6 and just start using it. It's pretty cool. Awesome. Next one, trail enclosures. This also is probably not going to be a huge cause of issues for you, but these were warnings actually that were already there. But enabling this feature flag actually makes it into errors. Now, I have to say, I don't fully understand what this does exactly. I know how it breaks, so I'm going to tell you how it actually breaks. But I have to say, after reading the Swift evolution pitch, I'm not sure I understand exactly how it works. So let's say you've got a test truck, right, that has two closures with default parameters. So how do you actually initialize this? So technically, you could initialize it with one trail enclosure, which is the first one, or with another trail enclosure. So up until this evolution proposal, the way it used to work is that you could basically do this, the structure of A, so one parameter only, and this would actually match to the first closure over there. Then if you initialized it like this, with two parameters, expecting two parameters, it would match to the second closure. The way this used to work is through backward scanning. So it would start on the latest parameter, on the latest closure, and it would scan backwards through the closure until it found one that actually matched. This actually yields a warning because it's no longer supported. And what this proposal actually does is it changes so that it becomes an error. So when you enable it, you basically get some code that looks a bit like this. So the first one is okay because it's now forward scanning, so from the beginning up until the end. But you can't actually now use the second closure for multiple trail enclosures. You can't actually use it just like that. You need to give it a name parameter because you've got multiple closures and it becomes a bit confusing, essentially. So again, read the Swift evolution proposal. Maybe you will understand it a bit better than me. But this is the actual implication, right? So that second case where you've got multiple potential trail enclosures, you can't really match the one after the first one, basically, without the named parameter, as you can see on the third example, as it will give you an error. Awesome. Another pretty confusing one that I want to talk about is implicit open existentials. So let's consider you've got a protocol with an associated type, or a protocol that has some generic type underneath that the compiler needs to know about. So one example is conforming your protocol to equatable. So let's say you actually want to make a method that takes this as a parameter, and you want to pass it like this. So you just want to pass with self-requirement, right? This is not really possible. So you basically need to specify, at this point, you need to tell the compiler that at the client side, you should really know and you should specify what the underlying type of this parameter is. So you've got two ways of fixing this error. One of them is making the function generic over this, this with self-requirement. And the other one is putting it into a box, right? So you can basically say any with self-requirement. I don't think Apple encouraged this too much, but it's an actual solution that you can have. And this is kind of equivalent to those type-erased solutions that you used to have with any codable or any hashable, stuff like that. This is kind of equivalent to what you used to have. Now, up until this proposal, if you wanted to then use this type in another method that required the actual underlying type to be known to the compiler, this wasn't really possible, right? So if you wanted to call it like this, with an open existential, and you wanted to convert from an any, so you had a box with some underlying data type, and you wanted the compiler to know and use this underlying data type, you would need to actually specify it in the caller as well. With this proposal, the existential, so the box is basically opened, and you get the underlying data type directly, so you can use it like this. You can pass an existential directly into one that's a generic function, for example. I have tried it. It's implemented from Swift 5.7. I believe this works already without enabling the feature flag, but I went on a bit of another unnecessary rabbit hole, and I looked for cases where it wasn't actually supported. So I was of this person's opinion that it was actually supported. And they were like, okay, I've copy-pasted literally every code in the proposal, and everything's working without the upcoming feature flag. And then I came across this comment from Joachim Hasila, who maintains the Ordo One open source project, which does a lot of cool like benchmarking and stuff for SwiftCode. And they had one edge case that wasn't covered and supported for this. And this was that they were actually using an any of a type declaration. So this is extremely confusing, but if you try this code and you pass it to a generic function, you will basically get an error saying that it can't actually open the existential for you. If you enable the upcoming feature flag, this will absolutely work out of the box for you. So if you do enable upcoming feature, yeah, you can basically do this. If you encounter any of those issues where you're using an existential and then you're trying to pass it to a method where the compiler requires to know the underlying data type, try this. If you've got an error, try this and see if it works for you. You can basically start adopting it. I believe it was implemented in 6.0, so maybe you might need to wait until that toolchain is available. But yeah, this is a pretty cool example of something that the Swift team have been improving in terms of existentials. Awesome. Another one that's very, very simple to fix. I really like this small quick wins, and it's particularly good for code bases that are very, very legacy. I used to work in a code base that had a ton of Objective-C, and it was, I think, over like 12 years old. And it had a lot of like fun. I kind of miss the code base, to be honest. Like it had a lot of fun problems and stuff and challenges that you had to fix. So if you've got a very legacy code base, very legacy application, you might need to consider this because it's an error that's going to come in the Swift 6 language mode. Very, very easy to fix. So back in the day for AppKit and UIKit, you used to define the entry point for your applications with NS application main and UI application main. Again, this might sound like a weird language to you if you've used Swift UI and you're used to the add main decorator. But basically, you now have two ways of defining the entry point of an application. So you've got UI application main or NS application main, which is the legacy that's not really supported anymore. Or you've got the add main decorator, which is what you should be using now. Very, very easy fix, very easy to kind of like implement and stuff, but it's hidden for source compatibility reasons because it's going to become an error. It's hidden behind an upcoming feature flag, basically. So as soon as you enable it, you'll get a warning like this, saying that you shouldn't really be using it. It's going to be an error in Swift 6. So yeah, all you have to do is literally replace that with add main. Super, super easy win, but something that I wasn't aware of either. So yeah, just making you aware that that's going to be the case in Swift 6. Right, so I've got to the favorite point of, like my favorite point of the talk. This is a feature that I've been wanting for a very, very long time. And this has potential for breaking a ton of stuff, okay? Particularly for modular code bases, but it's something that's fairly easy to fix. And I'm gonna give you a script that actually fixes everything for you. So if you wanna adopt this and start changing your application to use access control on imports, you can start doing that now. So up until now, this is the way we declare import statements on our application, right? So there's nothing else you can actually do. But then from this proposal, you can basically add access control to your import statements. So you can use any access control like you do with property declarations. You can use it on import statements, basically. So what does this actually mean? So if you try to do, for example, a private import of a dependency example, and then you try to expose any of the types that are in that dependency that you're importing with the private import in an interface that has higher access control than your import, it will actually fail. So for example, private import I shouldn't use a type in a public function, basically. I tried this with something weird that I found that I think I'm going to file a feedback for. If you have a protocol and you use a type inside the public protocol, I think it kind of works when it really shouldn't if you've got a private import. So I think I'm gonna file a feedback for that. But this is super, super handy because up until now, when you did an import, there was no way of actually hiding these dependencies to the client. So let's say you had like a module that was home and you had like home core and home UI. You literally want to expose the home module, but implicitly, if those dependencies were static, and you could basically import them from your client, right? So you could do home core, import home core or home UI directly from your application target, let's say. This comes to fix this. There's some like nuances as well that I haven't quite like figured out because I'm still able, if there's static dependencies, I'm still able to import them. But this kind of comes to fix this and to replace some underscored attributes that were used in the past to do this exact same thing. So the way you enable it is again through an experimental feature, which is called access level on import. And as you might imagine now, how does this keep source compatibility, right? So how does the normal import dependency, which is still valid, how does that map to an access control? What access control has the default import with no access level control modifier? Well, basically by default in the Swift 5 language mode, it's going to be public. So you can basically share it and use it anywhere. I do not recommend making your imports public, more if it's just think about whether you should be using those types outside of the of your module, and if you should be leaking those implementation details from either external or internal dependencies. Now, the breaking change comes here in Swift 6 language mode, and for me, this makes a ton of sense, is that they're making these imports internal. So that means you can declare any, with the normal imports, you can declare any public interfaces that use types from your dependencies and are gonna, and are exposed publicly to the users of your library or framework. So again, breaking change. So this comes as an upcoming feature that you need to enable alongside an experimental feature. And it's called internal imports by default. I would thoroughly recommend start testing this now. It has a lot of potential for like making your APIs like a lot cleaner. It could flag a lot of architecture decisions that you have made and maybe you're not aware of because of the public import declarations that you're leaking to outside your module. So yeah, I would recommend checking that out and starting to take a look into that feature. If yes, you can see this has potential to break a ton of stuff when you enable this, this upcoming feature. So say you've got your dependency example module that has a struct called dependency example. If you expose it in a public type, this is going to be an error, basically. So you might have, I don't know, hundreds of these across your code base that you're going to need to check out. Thankfully, these hundreds are not going to be as hard to fix if you want a quick win and fix it very, very quickly, are not going to be as hard to fix sometimes as strict concurrency checking. You can basically take the script if you want. It will scan through all of the Swift files in your project, and it will change the imports to public import, basically. So you can go back to Swift 5 language mode by being explicit about public. Personally, I would do the opposite. So I would take all of your imports in your project and I would make them all private and then work through the errors and try see if you actually need to expose those types outside when you get an error. See what you actually need to change and increase only the access level when you actually need it. The reason why I'm saying this is because this has linking implications. So sometimes when you don't have a public import, it might not need to bring the dependency with you over to the final client, reducing the size of the binary. So yeah, it's got like some implications as well. It's fully outlined in the Swift evolution proposal, but I would thoroughly recommend checking this out because it's got a lot of potential. And also, this could say goodbye to this implementation only underscored attribute that I know a lot of us have used in the past. There's also the at exported one where you could just basically reshare your dependency and export it to the outside world from your module. So yeah, this could say goodbye to this, basically. I don't think it quite says, like deprecates this in all cases, but I think that's the point and that's the motivation from the Swift team is to kind of like promote this to production level and to stable level by through the access level modifiers on the import statement. And there's one last one. I'm not going to bore you anymore with any more proposals. That's all of the breaking changes that you've got, and you've got all the slides that I'm going to share so that you know how to enable them. And there's one more proposal that I'm actually not going to talk about, which is Objective-C forward declarations. So as I said, in my previous job, we had a very legacy app, so I had to work a lot with Objective-C. I still don't think I understood fully what forward declarations are. So before I embarrass myself in public here speaking out forward declarations on Objective-C, I'm going to let whoever wants to read it just scan the QR code and have a look through the proposal. And maybe you can actually explain it to me. I might learn something about forward declarations. If you actually want to come chat to me about it and explain properly how forward declarations work, I would, appreciate it, actually. And yeah, even though I've talked mainly about the breaking changes, because that's the thing that's going to catch you out the most, I would recommend you to check the non-breaking changes as well, the things that the Swift team have actually been working on and that are going to be on by default with the Swift 5 language mode and Swift 6 language mode. So these are going to come already out of the box enabled with the Swift 6 toolchain when it's launched. So whenever you update to that Xcode beta version, you'll be able to use all of these changes, basically. For me, one that I'm particularly excited about is the parameter pack iteration. So I don't know if anyone's used parameter packs in the past to write some APIs. My opinion, I think they've got tons of potential. They'll solve a lot of problems with generics. But I personally think they're pretty unusable as it stands because it's quite hard when you've got some arguments that are parameter packs. You can't really iterate through them as it stands. So they've built a proposal where you can basically use them as a sequence, essentially. So you can do a for each with parameter packs, which is super handy. And yeah, that's one of the things that I'm most excited about. And it was a lot of hard work to actually find all of the evolution proposals that were breaking changes and actually map, feature flags and actually enable them all. And finding which version the feature flag was actually implemented versus which version the actual implementation was. So I decided to make this map for you and for myself as well, for whenever I have to enable and want to try a new feature. You could use it as like a bingo card, basically. You could use it as what's going to break. You can start ticking things off as you try them. And yeah, this is basically mapped. So you get, whenever there's a feature flag, you know which version it's in. And if that comes accompanied with an experimental feature, you know how to enable it as well. I'm going to share the slides as well after the talk. So if you don't have time to take a photo, I'll basically share everything afterwards. And that's pretty much it for me. I'm aware we probably have a ton of time still. I think I think we're good on time, I guess. But yeah, if you've got any questions, feel free to check out Helm, obviously. And if you've got any questions, here's where you can find me online. I've got pretty much every social media under the sun, so you can find me there. And yeah, I've hit my quota of social media accounts, so I'm not going to add any more. If you've got any questions, ask them now or find me later or ask me online, however you want. Thank you.